Section 1.4 is called Using the Definitions of Trigonometric Functions. And we're gonna again use here quotient identity, Pythagorean identity, and so on. So the first question here is, decide whether this statement is possible or not impossible. Actually, this sine squared of any angle plus cosine squared of the same angle equals to a 1. This is a very important identity in our trigonometry class. This is called Pythagorean identity. This is the main identity. There is two more versions of this identity, but this is the main one. So we're going to choose here, this is possible because not sine theta plus cosine theta. It has to be sine squared plus cosine squared theta equals to a 1, has to be an identity. This is how we do question 1. For question 2, the question says, use the appropriate reciprocal identity to find the exact value of secant of theta for given cosine of theta. So the reciprocal identity we have to remember here is secant of any angle is always 1 over cosine of the same angle. So this is the reciprocal identity that we need for question 2. So that means 1 over cosine of theta means just get the reciprocal of this fraction. So secant of theta will be just the opposite reciprocal of cosine. So it's going to be 9 over 4 for this question. So we need a 9 over 4 here. For question 3, so again, it says use your reciprocal identity to find the cosecant of theta. So cosecant of theta is equal to 1 over sine of theta using the reciprocal identity. So since sine of theta is given as negative 8 over 9, I can just flip over my fraction and get a new trigonometric ratio as negative 9 over 8. Negative 9 over 8 is what I need here. Next question is, again, about the reciprocal identity. I have the tangent value and I'm trying to find the cotangent of the same angle. So cotangent of any angle is always reciprocal of the tangent value. So if I just get the reciprocal of 7, which will be 1 over 7, this is what I need for this question. If tangent is 7, cotangent will be 1 over 7 because they are reciprocal of each other. For the next question here, it still asks me to use the reciprocal identity. So I have the secant value and I need to find the cosine theta. So cosine is always reciprocal of secant, or secant is always reciprocal of cosine. These are the two main reciprocal identities. The other very famous one is sine of any angle is always reciprocal of cosecant of theta. And then in other words, cosecant of theta is always reciprocal of sine. So these are called reciprocal identities. So when we go back to this question, question 5, so cosine of theta is the reciprocal of secant of theta. When I get the reciprocal of this fraction, it will be still a negative number. And instead of 11 over 2, I just need negative 2 over 11. So I just need here negative 2 over 11 as an answer. For question 6, we have the cosine value. Use the appropriate reciprocal identity to find the exact value of sine of theta when you have the cosecant of theta given. So here, we can still use the same rule. Sine will be the reciprocal of the cosecant of the angle. So to find the sine of theta here, I need to get the reciprocal of this fraction, which is 4 over root 28. I am not going to be allowed to leave a radical in the denominator, but before I rationalize this, I want to simplify this square root of 28. When we look at square root of 28, 28 is 4 times 7, and then 4 is a perfect square number. It goes outside as 2, and then the 7 stays inside the radical. So the answer is 4 over 2 radical 7, but we can't keep the radical 7 in the denominator. So this is the rationalizing part. So when I do simplify this part, numerator will be 4 radical 7, and the denominator will be root 7 times root 7 is just 7, and 2 times 7 is 14. This answer will still not be accepted by the software since we have to simplify. 4 and 14, I can divide both of them by 2, and I can make them 2 out of 7, and radical 7 stays as it is. So here, we will need a division sign. At the top, I need to write 2 radical 7, and at the bottom, I need to type my 7 and check my answer. That's how we do question 6. For question 7, we have the cotangent of theta, and we want to find the tangent of theta. Now, we already know that tangent of any angle is always equal to 1 over cotangent of theta, because tangent and cotangent, they are co-functions. So the value of one of them will be the reciprocal of the other one. So when we look at this question 7, cotangent of theta is given as 0.2, but I really don't like this decimal value. I want to convert this to a fraction. 0.2 is the same thing as 2 out of 10. 2 out of 10. I can even simplify it as 1 over 5. Now, to find the tangent value of the same angle, all I need to do is find the reciprocal of this fraction, which will be 5 over 1, and 5 over 1 is simply 5. So we just need to type a 5 here, and then we need to check our answer. Next question will be, find the signs of the 6 trig functions values, signs of the trig function values for the given angle, 184. So when we look at 184, this angle is in quadrant 3. So we have a quadrant 3 angle. So if we show, this is quadrant 1, this is quadrant 2, and this is where quadrant 3 is going to be. So when we understand the signs for quadrant 3, x-axis is the cosine value, and it will be a negative value because all these x values here, they're negative numbers. So in quadrant 3, cosine is negative. Sine will be negative as well because sine is y values, and in quadrant 3, all y values are negative, so sine will be a negative number. Tangent is, because tangent is sine over cosine, and when you divide negative by negative, you will get a positive answer. Cotangent will always have the same sign as tangent, so their sign will be always the same thing. Secant will be the sign of the cosine because secant is reciprocal of cosine, and cosecant is the sign of sine, which will be negative. So sine will be negative, cosine will be negative. That makes tangent to be positive. Cosecant uses the same thing as the sign of sine. Secant uses the same thing as sign of cosecant, cosine. And cotangent is going to be the same sign as tangent. So only two things will be positive and rest of the things will be negative here. So now, next question is an angle which is going to be in quadrant 2. So when we think about quadrant 2, because 149 degrees, this is an angle whose terminal side is in quadrant 2, and then this is the quadrant 2 region. So again, this is our cosine values. These are sine values, okay? So that makes our sine to be a positive number because here all sine values are positive numbers. However, cosine will be a negative number. That makes tangent to be a negative number because tangent is sine over cosine. Cotangent is going to always have the same sign as tangent. And cosecant is going to have the same sign as sine, and secant is going to always have the same sign as cosine. So these are going to be the signs I need. Sine is positive, cosine is negative. tangent is negative, cosecant is positive, secant is negative, and cotangent is negative. And then this is how I am going to place the signs for these functions. For the next question here, we have a different style of problem. Find the exact value of each of the remaining trig functions for theta. Rationalize denominators when applicable. Sine of theta is given as √3/7, and theta is in quadrant 1. So this is important, knowing that angle is in quadrant 1, because we know that all these 6 trig functions, they will be a positive number. So if I have the sine, how can I find its cosine? In order to answer these questions, we can use 2 ways. We can use identities. So I can either use an identity to find it. The main identity who's going to help me here is sine squared of theta plus cosine squared of theta is always equals to 1. So sine of theta is given as √3/7. So when I square this and then add with cosine squared of theta, that must be equal to 1. √3 squared is just 3, 7 squared is 49, and then plus cosine squared theta is equal to 1. If we subtract 3/49 from each side, I am going to get 46/49 for cosine squared of theta. So cosine of theta will be equal to plus and minus square root of 46/49. That makes it cosine of theta. It is possible that cosine might be a positive number and negative number, but the questions specify that this is a quadrant 1 angle, so we're going to only use the positive value, and then the numerator is going to stay as square root of 46, but the denominator square root of 49, we can simplify it to a 7. So here I'm going to choose A, and I will tell them that cosine value of this angle will be radical 46 in the top, and I need a 7 at the bottom. And I will check this answer before other parts open up. Now, after we have the cosecant value, so let's just write now, what do we know about this? What do we know about this question, this angle? So the sine value was given. So sine value is given in the problem, and it's square root of 3/7. Cosine value, we use the identities and we get the value as square root of 46/7. Next thing they're asking is cosecant of theta. Because cosecant is always reciprocal of the sine, I just have to flip over my sine value. So this is the sine value. When I get the reciprocal of this fraction, I get 7/3, which I need to rationalize it, and it becomes 7√3/3. That's what I need. Remember, everything is positive in first quadrant. So here, the numerator is going to be 7√3, and then the denominator is just a 3. And we're going to check our answer. Next question is secant of theta. So secant of theta is, because of the reciprocal identity, it's always equal to 1/cosine of theta. So I'm just going to need the reciprocal of this fraction, which is 7/46. We need to rationalize the denominator, so it will become 7/46/46. So we're going to choose that we will have an answer for secant of theta. At the top, we need to write 7 and then radical 46. At the bottom, we just have to write 46. And then we just need to check our answer next. Now it's asking me to find the tangent of theta. So tangent is always sine over cosine. I can use this. This is called quotient identity. Its sine value is √3/7, and its cosine value is √46/7. And when I'm dividing two fractions, the rule is always copy the first one and multiply it by the reciprocal of the other one. So the top 7 and the bottom 7 simplifies, cancels out. And the answer is root 3 over root 46, but I just have to rationalize the denominator. So I need to multiply the top and bottom by radical 46, so the denominator just becomes a 46. I can just multiply these two numbers. 3 times 46 is 3 times 6 is 18. 1 is the carry, so it's going to be 138 in a radical and a 46 in the denominator. So we are going to choose tangent of theta will be, at the top, we will need square root of 138. At the bottom, we will need a 46. So the cotangent is just a reciprocal of tangent. So I think I can open room here. So if the tangent value here is root 3 over root 46, cotangent will be just a reciprocal of this, which is radical 46 over radical 3. Again, I can't give this answer to the software, so I need to rationalize the denominator by multiplying the top and bottom by root 3. So this will still give me the same top number as the other one, which was 138, but the denominator will be just a 3. So we're going to say cotangent of theta is, at the top, we will get square root of 138, and at the bottom, it will be just a 3. And this is how we can handle this question, question 10. I used a lot of identities to find a lot of missing trig functions. Next time I see this question, I'm going to show you another way. So for this question, it's exactly the same style as question 10, but instead of using identities, I want to show you another way this time. And this time, the question gave me the tangent value, and they're telling me that the angle is in quadrant 4. Why is this part very important? Because I have to think about all the signs in quadrant 4, whether the sign is positive, cosine is negative, so that makes tangent to be negative, and so on. So this in part is important, but what is important is tangent is negative 8 over 15. We can definitely solve this problem using the identities like the other question, but this time I'm going to actually use the triangles, right triangles. And I just have to make sure that it is a right triangle. And I can either place my theta over here or I can place it here. It's up to me, so I'm just going to put my angle theta here. Now, the tangent value is given as 8 over 15 if I ignore the sign for a moment. Tangent of any angle is always opposite side divided by adjacent side. So its opposite side is 8 and its adjacent side is 15. And for other trig functions, I still need to find the hypotenuse value. So we know that we need to use Pythagorean identity for this. So if I just label this as C squared is equal to 8 squared plus 15 squared. So C squared is 64 plus 225. So C squared is equal to 279. That makes C value to be square root of 279, and that's a 17. So the C value here will be 17. So Pythagorean must be a 17. Now, I have all the dimensions here, and I can use SOHCAHTOA to answer the rest of the trig functions. Sine of any angle is opposite side divided by hypotenuse. So opposite of theta, we have 8, and the hypotenuse is 17. And I just have to think that in quadrant 4, this is where quadrant 4 is. So cosine is positive, but sine is negative. Tangent will be negative because negative divided by positive is just negative. Cotangent is going to be always the same sign as tangent. And secant is going to have the same sign as cosine. And cosecant is always going to have the same sign as sine. So therefore, sine will be this ratio, but it needs to be negative. So I'm going to choose A, and I will enter them. The answer is negative 8 over 17. And then we'll check the answer. Next part I need is, I shouldn't be erasing everything because I'm going to still need my triangle, but I do believe that we do not need the work for sine and the hypotenuse. So I'm going to delete this portion and I will just delete this part. So next thing I'm going to work on is cosine of theta. So cosine of theta. To calculate the cosine value, we need adjacent over hypotenuse. So the adjacent is 15 and hypotenuse is 17. I just have to check the sign. Cosine is positive in quadrant 4. So I'm done with cosine. I will enter here 15 over 17. Next thing I need is the cosecant of theta. Now we know that cosecant is always reciprocal of sine, so I don't have to do the work. We already know that sine is 8 over 17, so cosecant will be just 17 over 8. I just have to check the sign. It's positive because cosecant is the reciprocal of sine. So that means I made a mistake here. Since sine is negative, cosecant must be negative too. So this will be a negative 17 over 8. Next question is secant of theta. Secant of theta is the reciprocal of cosine. So since we have the cosine, we just need to flip this over 17 over 15, and I have to check the sign. Secant will be positive, so it's going to be 17 over 15. And cotangent of theta, it's adjacent over opposite, so it will be 15 over 8. And again, cotangent must be negative in the quadrant 4. So we will need to enter here. We need a negative 15 at the top and 8 at the bottom. Next question is for this lesson. It's pretty much the same idea. So I'm going to let you explore this. If you have the sine value and cosine is given negative, so when you look at the signs, sine is positive, cosine is negative. This is only possible if the sine is a positive value. Sine is positive, so sine is the second value. Sine is positive only in quadrant 1 or quadrant 2. But quadrant 1, sine and cosine, they're both positive. Quadrant 2, cosine is negative, sine is positive. So here, since cosine is negative and sine is positive, you're dealing with an angle who is in the quadrant 2. So you can either use identities or you can use right triangles for this question. And that's all for section 1.4.